Vibration of a circular membrane. Mathematical equations that governs the vibration of the drum head is the wave equation. When we talk about the wave equation in two-dimensional, we consider the example of a string. And we talk about the wave equation in the three-dimension, we'll consider the membranes. For circular geometry, it will be convenient to use the cylindrical coordinates r, theta, z. Then consider the wave equation, that is partial square z over partial t square equals c square partial square z over partial r square plus 1 over r partial z over partial r plus 1 over r square z over partial theta square. With boundary condition z of r theta t is equals to 0. Consider the circular membrane. Its edges are fixed. Since its edges are fixed, therefore we consider the boundary condition equals to 0. This is the radius of the circular membrane. We will solve this using the separation of variable method. Assume the solution z of r theta t as u is a function of r, theta is a function of small theta, and capital T is a function of small t. R, theta, and t. I will find out these values. That is basically I will differentiate this z with respect to t 2 times. I need its value, and all these values, partial square z over partial r square, partial z over partial r, and partial square z over partial theta square. Basically I calculate these 4 values from this equation A. Partial square z over partial t square, I will differentiate it with respect to t 2 times. These functions will remain unaffected because they depend upon r and theta, and I want to differentiate it with respect to time. So I will just differentiate t, and u and theta will remain same, and t will become partial square t over partial t square. Similarly, if I want to find zrr, that is derivative of z with respect to r 2 times, I will differentiate this equation A 2 times with respect to r. Since it is with respect to r, so only this function will be affected, u of r, and all the other functions will remain same. Since it is differentiated 2 times, that's why u is shown by u double dash, that is 2 times the derivative of u with respect to r. Similarly, zr is the partial z over partial r. So it will become partial u over partial r into theta into t. Theta and t will remains the same. And z theta theta, so only the theta function will be changed and all other functions will remain the same, u and t. And theta will become partial square theta or partial theta square. Now I will use above these values. I will use above all these values in equation 1, that is this equation. Equation 1 was basically ztt equals c square zrr plus 1 over r zr plus 1 over r square z theta theta. The values I calculated above, I used all these values in this equation. Just put these values in equation and I have rearranged it. C square is multiplied over here, so I will divide it here. And this whole equation will remain the same. Now dividing both sides with u, theta and t. I divided both sides of equation with u, theta and t. Similar things will be cancelled out. Here I cancel theta with theta, t with t, and theta with theta, t with t, and u with u, and t with t. So I will be left behind with this equation. Now I will let this whole equation equals to minus times alpha square. Let this equation equals to negative alpha square. Now I got two equations. One is for this thing, 1 over c square t double dash over t equals to minus alpha square, that is written over here. And the other equation will be this one. First I consider this equation, that is 1 over c square t double dash over t equals to minus alpha square. I rearrange it, t double dash equals c square and t are multiplied in the right side, and then these negative will come on the left side and I will get positive. So I got one equation, t double dash plus alpha square c square t. This whole equation is basically function of t. So I will solve this equation for t. Now consider the second equation. Consider the second equation and rearrange it. I simply multiplied both sides with r square. Multiplied the both sides of equation with r square and I got this equation. After multiplying the whole equation with r square, I simply moved this alpha square r square on the left side and this theta double dash over theta on the right side. I got this equation. Now again, let this whole equation, now you can observe that the left side is depending upon r, u of r, and the right side is only depending upon theta. I have wholly separated both the functions. Now let this equation equals to beta square. I will again get two equations, one for this one and the other for this. Consider this equation, r square u double dash over u plus r u dash over u plus alpha square r square equals to beta square. That is this one. Again, rearrange this equation, multiply u on both sides. After multiplying u on both sides, I just moved this on the left one. And after moving it on the left side, just take common u from these two values. I got equation number 3. This equation number 3 will be solved for the value of u. Now consider the second equation that I derived from here, that is negative theta double dash over theta equals to beta square. Rearrange it, multiply theta on the both sides and I will get this equation. This negative, I will move it on the left side. I will get theta double dash plus beta square theta equals to 0. This is equation number 4 and solving this equation number 4 will give us value for theta of theta. Consider, I first solved this equation number 4. Consider equation number 4. It can be written as d square plus beta square is equals to 0. For I am basically finding the roots. This beta square will become minus beta square on the right side, and after removing this square it will become plus minus iota beta. Now this equation can be solved for two values of beta. If beta becomes 0, then my equation will be reduced to d is equals to 0 and its equation can be written as theta equals a1 theta plus b1 e power 0 theta, since I got 0 as a root. So my equation will reduce to theta equals a1 theta plus b1. Now the main purpose is to find out the values for these constants, unknown constants. So I will use the condition, periodic condition over here.